Alright, now we get part 2 of scientific notation. So, if you have a big, gigantic number, I guess that's not too gigantic, depending on what you're comparing it to. But again, scientific notation is a way to write numbers like this as a product of a decimal and a power of 10. For example, I could write this as 4.25 times 10 to the power of 1, 2, 3, 4, 5. I moved over 5 places. So 10 to the 5th power. So again, this would be standard form, my big answer. And this right here is scientific notation. Scientific notation. I gotta write that really fast for you. Okay, so again, with scientific notation, it's a decimal times 10 to some power. Now, here's the deal with the decimal. The decimal always needs to be greater than or equal to 1, but it needs to be less than 10. It has to be less than 10. So, you can't have your decimal be like 10.52. So I always like to tell kids, it's really just, if you think about it, you need to only have one digit to the left of your decimal. Only one digit right there. Okay, so let's give it a try. So I want to write 3,600,000 in scientific notation. Because remember, again, this is standard form. I need scientific notation. So right away, I know that I need a number and a decimal, and I don't know what's going to be after it, but it might be 1, 2, or 3. But all I know is that this number needs to be less than 10. Okay, so to do that, right away, I know that my decimal is going to need to go right there. I know that I'm going to need this to be the 3, and then from that, and then after that will be the 6. So how do I get... Oh, I have a sneeze coming in. Hold on. Oh, okay. So I know that my next number will be a 6, but what I need to know is 10 to what power? Okay, so that's what you need to help me figure out here. So to do that, it's exactly the same as when we did the other video. You know your decimal is at the end right here. So how many times did I move it to get to right there? So let's count. 1, 2, 3, 4, 5, 6. So that's how I get my exponent up here of 6. This would be the scientific notation to represent that big number. Okay, what about this? This isn't a really big number, but it has a lot of digits. It's actually a really small number. So you can even do really small numbers representing with scientific notation as well. It's the exact same thing. You know that you're going to need to have a number less than 10 here. So I know right away it's going to be 3.6. But 3.6 times 10 to what power? What is that going to be? So, again, you come over here, and you want your decimal to be right there. So how many places do I move it? 1, 2, 3, 4. Now, common mistake, kids just put a 4 and they're done with it. If you were to check this, 10 to the 4th power means I need to make this a lot bigger. It means I need to multiply that number by 10,000. But that's not what I want. I want it to be a lot smaller. So, we know that we move it 4 places, but you should also be thinking it's going to make it a lot smaller. So what do I do to this exponent to make it a lot smaller? It's not multiplying by 10, I'm really going to be dividing by 10. Well, you should be thinking, well, to be dividing by 10, it should really look like that, which is the same as this. So when you start with a small number like this, just know your exponent's probably going to be negative when you're doing scientific notation. So this is your final answer for that one. Alright, I have 3 examples that we're going to go through. If you think you've got this, why don't you just pause it and try it and then check in. If you don't, then just do these examples with us on your paper. Hopefully you're setting your notes up so you can use them as a study guide for later. Okay, so we have a big number. Right away I'm thinking I'm going to need to do something with a decimal times 10 to some power. I don't know what yet, but I know it's going to be a positive number because this is a big, big number. Okay, so I know that I'm going to put my decimal right there because I need it to be less than 10. So right now I'm going to count how many places I move the decimal. Start at the end. 1, 2, 3, 4, 5. So right away I know my exponents is going to be 5. My decimal is 2.57034. I have to write all of that, and I don't know if I have room. Oh boy, almost there. Haha! And there's a big fat decimal right there. Alright, that is my answer in scientific notation. Alright, ooh, now the next one. I have a really tiny number. So, right now, because I have a really, really small number, I can still use scientific notation to represent it, but I know right now that my exponent is going to be a negative, because I know I'm really dividing by 10, because when I move the decimal this way. Okay, so I know it's going to be 10 to the negative power. I do that, and then I count how many places. Where am I going to want my decimal, though? Where do you think? Do you think here, here, or here? Okay, hopefully you said here, because it's going to be 7.27, because I need it to be, again, less than 10. So let's move it over. 1, 2, 3, 4, 5. So erase this and make it all look neat. Okay, so I need 7.27 times 10 to the, oh no, I forgot what I just counted. 1, 2, 3, 4, 5 to the negative 5th. So that is my answer in scientific notation. Again, if you want to check it, like up here, again, it was to the 5th power, so I know I'm going to make that number a lot bigger because I'm really multiplying it by 1, 2, 3, 4, 5 by 100,000. Okay, and then down here, I'm multiplying it by 1, 2, 3, 4, 5, 100 thousandths. So you're making it a lot tinier, and that is a tiny number. So you're good to go. Okay, now, last one. How do we do here? Okay, I need to make it a number that's less than 10. So I'm trying to figure out where I should move my decimal. Right now I know I need to put it right there, in between the 1 and the 2. So that's going to be my 1, 2, 6, 9, 3, 5 times 10 to the, I first have to think, is it going to be a positive or negative number? I'm kind of starting off with a bigger number than 10, so I know it's going to be positive. So let's see, 1, 2, move it over 2. Again, check your final answer. If you had to multiply this number by 100, would it look like that? 126.25. Would it look like that? Yes, it would. If it was a negative exponent, you know it wouldn't look like that. So just make sure you're using common sense and number sense to get these right. Okay, I have 3 problems that I want you to try. When you're all done, I'm just going to give you the answers. If you still have questions on how to do it, we'll go over in class. But right now, try the video, try these 3 problems, then unpause it, check your answers. Okay, voila! Here are your 3 answers. If you got them wrong, try to figure out where you went wrong. Was it with the exponent, the decimal? Is the negative exponent giving you some trouble? So if you're getting these wrong, write down what you need to ask your math teacher tomorrow about. What is the most confusing part, so they can help you with it. So sometimes it just takes a lot of practice. All right, have a great, fantastic day or night or whatever is going on. Okay, bye-bye.